Hi, everybody. We're gonna get started today. I have one question up there so far, and we'll start with that. I just need to capture the PDF first. That's a little big. Oops, hold on. All right, hopefully that's big enough on the screen. I gotta move this over here so I can see it. Oh, that didn't work. There we go. Okay, so let me make sure I'm not writing on that, but so the question we have is, and now I can't see it because it's hiding behind a window for me. How do you do part B and C on question 5 of the pre-lab? So let me, oh, I need my tablet. I got the pen out and I start writing on the paper. And I'm like, this isn't doing anything. That's not what I want at all. There we go. All right, so first we got to do question A because we need to answer that. So let's draw a picture. So I have, here's my little weighing, but no, let's not do blue. That'll be the compound. Here's my little weighing boat. And inside this, I have my washing soda. So here's my washing soda. And the mass of this sample is 1.00 grams. And then I heat it. And what remains now weighs this much. And so for question A, we need to figure out what the mass of water was that was removed. Now, after heating this, all the water escaped, right? And due to the conservation of mass, the mass that we started with has to equal the mass that we end with. So I should be able to add these two numbers together right here to get 1.00 grams. Or in other words, I could just subtract them, right? So if I subtract them, I get that. And then when I deal with sig figs, I got to chop my numbers off here. So you should get that. So that's the mass of water that's in the sample. So that's A. And then question B says how many moles of water were removed from the hydrate? Well, if I know the mass of water, I can then turn it into moles. So for B, we would do something like this. Kind of like with the problems that we were doing in the previous unit where we were converting grams to moles and then using the moles for something, right? So if I go to Lentech and I look up the molar mass of water, I get this, 18.02. And so when I do this math, I get 0.03496 moles of water. I only get to have 2 sig figs, so I will write 0.035. So that's how we do that. And then question C is how many moles of anhydrous sodium carbonate are produced? Well, up here in my diagram, here's my water, which we just calculated had a mass of this. And this is my washing soda. So over here I had, we'll write the formula out here. This is what was here at the start. This is what this is afterward. The H2O is what gets evaporated out, right? So for part C, how many moles of anhydrous, that's this part that doesn't have water in it, how many moles is that? So we can convert that to moles. So first we'll take its mass, which was this, and then we'll convert to moles in the similar manner that we did up here. And this one I have to look up on Lentex, so let me go get that. Maya, no. Maya, no. I say Maya, no, until she responds with meow. Okay, so 105.99. So when I do that calculation, what do I get? I get 0.367. 0.03462. And I get to have 3 sig figs due to this number over here. And so that's part C. And then for part D, you're going to use this number and this number to make a ratio. So more or less, this experiment and all the questions that I ask you are going to be like the problems that we did in Unit 13. So that's the number that you got. So what we'll do is we'll treat it like it was a problem in Unit 13. So let's write the ratio here. So I have 0.00346 of this to 0.035 of this. Excuse me. And then what do we do when we have a ratio with numbers? Now, note that these aren't the same. There's an extra 0 over here. So the left side is smaller than the right side. What would you do when you have the molar ratio of these two things? And I'll just write moles so that that's clear. What do we do when we get to this step? I'll give you a hint. Think of this as kind of like our formula, where we have 0.00346 sodium carbonates and 0.035 water. What was the step that we did? And my hint is it involves doing something like this. So that's balancing equations. We don't want to balance it. We want to do something with something mathematical. What can we do that involves math here? Maybe to get one of the numbers to become 1. What would we do? Oh, excuse me. Okay, what do you do though? You gotta tell me. I can't just leave the problem like this. Like, what am I doing here? What's the next step? Yeah, there you go. You divide by the smallest number. So that's this. And so this over here would then become 1 Na2CO3. And then when I do this for water, you should get 10, I think. Yeah, 10.115. That's close enough to 10. So now you can write the formula of this. And there you go. So that's how you do the first one. And in fact, you do every problem in this experiment just like this. Which is why we have this pre-lab question here, because if you could do it here, you could do it on any of the other problems that we ask you. All right, that's basically that question. So if you have other questions, let me know. I'll leave this up for a second, and then I'll put the title card back up, and then we'll just keep playing more music until more questions are asked. So that it's not just playing dead air. I have this feeling that YouTube really doesn't like that if I just have silence. I mean, when you're working and doing practice problems, like, what can I do? But all right, so type anything in the chat that you might have questions about, and we'll start up the music again here. And I'll see you in a bit. Alright, it doesn't look like I have any more questions, so I'm gonna wind the stream down here. Hit me up in the Discord if you have any questions for me, or send me an email. I'll be happy to answer it. Have a good one. I'll see you tomorrow for Unit 15.